Tensor G1 launched with the Pixel 6 in 2021, and Google's philosophy was radical. Deliberately, provocatively radical. While Apple and Qualcomm were chasing raw speed numbers, Google said, "Forget benchmarks. We are building a chip for artificial intelligence. On device, no cloud, no waiting, no internet required." To achieve that, Google made a hardware decision that puzzled the entire industry. 2 Cortex-X 1 prime cores instead of 1. The logic was that spreading workload across 2 moderate-speed cores would distribute heat and power more gracefully than pushing 1 core to its limit. The logic was reasonable. Samsung's 5-nanometer manufacturing process made it irrelevant. Heat built up faster than the design could manage. The chip throttled, meaning it automatically slowed itself down to prevent damage, almost immediately under sustained load. By the end of its first year on the market, Tensor G1 trailed Apple's A15 chip by nearly 40% in multi-core performance. 40%. That is not a close race. That is a different category. But here is the twist that keeps this story interesting. The software running on top of that compromised hardware was breathtaking. Magic Eraser removed unwanted objects from photos in seconds. Face Unblur rescued images even professional software could not recover. Live Translate worked entirely offline. HDR-net video processing transformed ordinary footage in real time. Competitors could not replicate any of it. Not because their chips were weaker, but because Google had designed something so specifically tuned to its own machine learning models that replicating the experience required replicating the entire architecture around it. Tensor G1 was a flawed masterpiece. Impressive from one angle, genuinely problematic from another. Tensor G2 arrived with the Pixel 7 in 2022, and the initial reaction from reviewers was somewhere between underwhelmed and confused. Same manufacturing node, same basic layout, same prime cores. The dominant narrative in the tech press was that Google had spent an entire year building essentially nothing. That narrative was wrong. The real improvement was quiet and structural. Google replaced the aging mid-cores, the Cortex A76 cluster, with newer Cortex A78 cores. Now, mid-cores are not the glamorous part of a chip. They do not dominate benchmark charts, but they handle the workload smartphones spend most of their time doing. Background tasks, browser tabs, notifications loading, email syncing. System operations that run constantly, even when you are not actively using the phone. Improving those cores did not make headlines, but it stopped the Pixel 7 from repeating the Pixel 6's thermal catastrophe. At the same time, the second-generation Tensor processing unit enabled Photo Unblur, a feature so specific, so oddly personal, it almost felt like a science fiction demonstration. You could take a blurry photo from years earlier, shot on a completely different phone, and Tensor would reconstruct missing detail from pure computational inference. That is not processing a photo faster. That is inventing information that was never actually captured by the camera lens. Behind the scenes, however, the deeper problem had not been solved. The industry had expected G2 to launch on Samsung's new 4-nanometer process. That transition never happened. Google shipped on the same 5-nanometer node again. The only conclusion the industry drew was that Samsung's yields on 4-nanometer were too inconsistent for mass production at the volumes Google required. The structural problem was still there. Tensor improved. The factory did not. Late 2022 changed the entire technology industry in about 6 weeks. ChatGPT launched. Suddenly, artificial intelligence was not a research topic or a distant promise. It was a consumer product tens of millions of people were using every day. Every major technology company began scrambling to reposition itself. For Google, a company that had been quietly building on-device AI into Tensor for 2 years already, the pressure became enormous. The response was Tensor G3, and it came with the strangest CPU configuration in modern smartphone history. 9 cores, not 8, not 10, 9. The industry had questions. 9 cores is an odd number in processor design. where symmetry typically serves efficiency? Google's answer was that the unusual layout distributed thermal load across Samsung's still problematic 4-nanometer node, just enough to sustain the generative AI workloads the Pixel 8 needed to run. The results were genuinely impressive in specific ways. Magic Editor rewrote photo composition using generative models. Best Take selected optimal expressions across group photos automatically. Audio Magic Eraser isolated and removed background noise from videos with startling accuracy. But here is where the story turns uncomfortable. On standardized AI benchmarks, the benchmarks every phone was measured against regardless of ecosystem, Tensor G5 collapsed against Qualcomm's Snapdragon. The Tensor processing unit was extraordinarily effective at running Google's own models. It was mediocre at running anything else. Google had built a chip brilliant inside its own world and average in everyone else's. Then came the controversy that the company has never fully explained. During the Pixel 8's review embargo period, multiple benchmark applications mysteriously disappeared from the Google Play Store. Reviews were already written. Embargo was about to lift. The apps were gone. Accusations spread immediately that Google was suppressing performance data before reviewers could publish unfavorable comparisons. Google never gave a satisfying public explanation. The story faded. But the image of a company managing optics around its own hardware had already settled into the industry's memory. Here is a question that sounds like a joke, but is entirely serious. What happens when a technology company decides that winning the benchmark war is actually making its product worse? Google found out with Tensor G5. The Pixel 9 launched with a chip that, on paper, looked like a step backward from an already struggling competitor. The experimental 9-core layout was gone. The GPU barely changed. The Tensor processing unit was largely recycled from the previous generation. In GPU stress testing, G5 lost to Snapdragon chips released 3 years earlier, and the Pixel 9 was Google's best phone in its entire history. The decision had been intentional. Google looked at its own return data and found a fact more damning than any benchmark score. The single biggest reason customers returned Pixel phones was overheating. Not camera quality, not software bugs. Heat. The phone was too hot to hold comfortably for extended sessions, so Google made an unusual engineering choice. It prioritized sustained usability over peak performance. It slowed the chip down deliberately to keep temperatures manageable under real-world conditions. The modem, finally, delivered acceptable efficiency. Battery anxiety largely disappeared from user reviews. Gemini Nano processed text, audio, and images entirely on device, without any cloud connection. Satellite emergency messaging worked without cellular coverage in remote areas. Tensor G5 lost every benchmark comparison it entered, and it powered the most satisfying Pixel experience Google had ever shipped. This is the central Tensor contradiction. Google is not building the fastest chip. It is building the chip most precisely optimized for the experience Google wants you to have, even if that experience requires deliberately sacrificing performance leadership. 4 years. 4 generations of chips, 4 years of heat complaints, throttling reports, and benchmark losses. And Google finally looked at all of it and asked the question it should have asked much earlier. What if the problem was never the chip? What if the problem was where the chip was being made? Internal analysis pointed directly at Samsung Foundry. Yield rates, the percentage of chips manufactured that actually function correctly and efficiently, were reportedly hovering around 50%. TSMC, the Taiwanese manufacturer that Apple uses, operates at close to 90%. That difference is not a technical footnote. It is the reason Tensor ran hot. It is the reason throttling was persistent across 4 product generations. It is the reason no amount of software optimization fully solved the problem. The decision, when it finally came, was straightforward. Tensor G5 would move to TSMC's 3-nanometer process. The same foundry, the same process technology, the same manufacturing partner Apple relies on. The performance jump was immediate and dramatic. Multi-core performance increased by 35% in a single generation. Sustained throttling nearly disappeared. Some workloads showed CPU scores more than double the previous generation. Google had not reinvented its chip architecture. It had not hired new engineers or developed new instruction sets. It had simply moved to a factory that built chips correctly. Inside Samsung, the fallout was reportedly significant enough to trigger emergency executive-level meetings. Losing Google as a customer exposed something the entire industry had been quietly acknowledging but not openly stating. Samsung's foundry business was no longer trusted for flagship silicon by the companies that mattered most. Here is what 4 years of Tensor actually teaches us, if we are willing to look at it honestly. Brilliant vision does not survive incompetent execution. Google had the right idea from day one. On-device AI, personalized hardware for personalized software, a chip that serves the experience rather than the benchmark. That philosophy was correct. The implementation was undermined at the foundation level by a manufacturing partner that could not deliver the physical quality the vision required. Every time Google released a software update to fix overheating, it was treating the symptom. Every time it tweaked core configurations and thermal profiles, it was managing the consequence. The root cause was always the factory. And until Google was willing to address the root cause directly, every other solution was temporary. Google looked. Eventually. And Tensor G5 is the result. What took 4 years to fix could have taken 1. That is the real story. If this made you think differently about the technology in your pocket, leave a comment below. Tell me which part surprised you most. And if you want to keep understanding the stories that actually explain how the world works, subscribe now. Every week, one story that changes how you see things.